I'm presenting my screen. Ma'am, is it visible my screen?
Yes, ma'am.
Okay. We'll create a project. New project. And it's will carry added. So project type, I'm selected it as RTL project. Then create source file. Triple carry added. Then constraints optional. Then go for the boards. Z board I've selected. Then finish. So ports. So I'm writing for the 4-bit triple carry adder. 4-bit is nothing but the input. A is taking A0, A1, A2, A3. B is also taking 4 bits, B0, B1, B2, B3. So it's A comma B, the buses, MSB, sorry, 0 to 3. And the initial carry as C. C is the input. I think only input carry is 1 bit, so not required the bus. Output, what you are going to get the outputs? You are going to get the outputs as S0, S1, S2, S3. So your sum should be output, and it is also selected as bus, and the output carry, which is also a single bit, so no need to select the bus. Ma'am, okay na? Indra madam.
Okay, okay.
Okay.
So it is updating, and the design sources, we are already created a source file with the name RC adder, ripple carry adder. .v is the extension for saving the file in Verilog. So ma'am, it is only program. It is visible na ma'am?
Visible.
Okay.
కొంచెం zoom it.
అంటే యాక్చువల్లీ లైక్ ఇక్కడ అదే ఆప్షన్స్ చూస్తున్నా.
ఫస్ట్ ఆప్షన్ అదే ఒకటే వస్తుంది.
ఏమో మ్యాచ్ కేస్ ఇక్కడ క్లిక్ చేస్తే ఏం ఆప్షన్స్ అంటే
అది సర్చర్
కదా మేడం, ఇక్కడ ఏం లేవు కదా దీనిది. అదే నేను అందుకే ఫ్లోట్ చేశాను అనమాట, ఓన్లీ ఒక్క ప్రోగ్రామ్ అన్న కనబడుతుందని. బట్ ఇక్కడ ఏం ఆప్షన్స్ లేవు. ఏమన్నా రైట్ క్లిక్ లో కనబడుతుందా? మస్తు చిన్నగా కనబడుతుంది నాకు. So already we have full adder. I think I saved the design file while creating the full adder design as full underscore adder. My guess, I just remember like that. With the instantiate, I'm instantiating or I'm calling this full adder here, and the sequence of, I think I just given the inputs followed by outputs. So we need to give the inputs followed by outputs while calling the full adder. So the inputs I'm taking, if the inputs are declared by the buses, you need to assign like a of 0, square braces you are going to use, a of 0, b of 0, and the initial carry as c. Then the expected outputs of s of 0. And the carry, intermediate carry, I'm just indicating with the C1. We'll declare it by wires, which are the intermediate carries which are generated. So intermediate carries, try to declare by wire. C1, C2, C3, I think enough. Try to copy the same for four times. So we are calling F0, the second full adder. The name is with the F1, third is with the F2, fourth with the F3, and the inputs are for the first full adder A0, B0. For the second one, it is A1, B1, and the output. Sorry, B1. Output of the first full adder is acting as input for the next full adder, that is C1, and the expected output is S of 1, and the intermediate carry generated for the second full adder is C2. Third is with the inputs A of 2, B of 2, and the output of the second full adder, that is C2, is acting as input for the third one, and the expected sum is S of 2. The carry is, intermediate carry is C3. The next full adder is F3 with the inputs A of 3, B of 3, and output of the previous, that is C3, is acting as input for this, and the expected sum is S of 3, and the final carry is C out. So C1, C2, C3 are intermediate carries. Actual carry is, initial carry is C, and the expected output is C out. Other than that, I think the total logic is covered. Is it now, ma'am? Jama?
Yes. Yes.
So
Yes.
save the file. I think, and that. If you are going to see here, the design sources, all the F0, F1, F2 full adders are given by the question mark. So if it is already there, you can use. I think it's there in my system. I'm just choosing its add sources. Next. Add file, add files, add files. Where are my this? D1 full adder. ఏమో రెండు ఉన్నాయి full adder. దీంట్లో సింబలే లేదు. So సెకండ్ full adder చూద్దామా. క్రియేట్ చేసింది బెటర్ మేడం. Day 1 full adder, second one లో I think sir told that now one symbol will be there, correct ma? Add sources.
డాట్ వి ఫైల్ ఉంటుంది కదా.
సోర్సెస్ అయితే ఇది ఉంది. ఫుల్
డాట్ వి
యాడర్
ఫైల్.
డాట్ వి. ఓకే యాడ్ అయిందా? ఓకే ఫినిష్. అంటే ఒకసారి ఓపెన్ చేసి చూద్దాం. లైక్ విల్ ట్రై టు ఓపెన్. ఐ జస్ట్ అటాచ్ వన్ ఫైల్. సో
ఎస్.
వాట్ ఈస్ ద మళ్ళీ ఓహో ఇది యాక్చువల్గా ఇది మేడం.
ఇన్పుట్స్ కమా అవుట్పుట్స్.
ఫుల్ యాడర్ కూడా లైక్ ఫుల్ యాడర్ ఈజ్ ఆల్సో డిఫైన్డ్ ఇన్ ద స్ట్రక్చరల్ మోడల్. సో ఇట్ ఈస్ ఆస్కింగ్ ఫర్ H1 H2. అర్థమైందా? అమ్మ ఇది మస్తు ఇలా చేద్దామని నార్మల్గా ఫుల్ యాడర్ యాడ్ చేద్దామా?
ఏం కాదు, ఇంకా ఆఫ్ యాడర్ కూడా యాడ్ చేసే.
ఓకే యాడ్ సోర్సెస్. నెక్స్ట్ యాడ్ ఫైల్స్. D1 half adder sources new half adder. Okay finish.
సీక్వెన్స్ చూడు, ఇన్పుట్స్ కామా సమ్ కామా క్యారీ, సేమ్ సీక్వెన్స్.
అదే ఇప్పుడు హాఫ్ అడర్ నేను అది చెక్
ట్రిపుల్ క్యారీ
చేయలేదు. అసైన్
ఫుల్ యాడర్ వరకు ఓకే, అది వదిలేసి ట్రిపుల్ క్యారీ యాడర్ లో చూడు.
లేకపోతే వన్స్ ఇంకొక ఫుల్ యాడర్ ఉంది కదా, ఒక్కసారి ఆగండి. ఇప్పుడు నేను హాఫ్ యాడర్ దగ్గర ఏమైనా మిస్టేక్ చేస్తే ఈ ఫుల్ యాడర్ ఇజ్ ఇట్ నా మ్యామ్? హాఫ్ యాడర్ ఓకేనా? ఏబి సమ్ క్యారీ.
క్యారీ దగ్గర అసైన్ లేదు.
ఆహా ఇక్కడ కామా పెట్టాను.
ఓకే.
ఈ ఫుల్ యాడర్లో చూడండి వైర్ S1 C1
కరెక్టే.
ఫర్ ద ఫస్ట్ హాఫ్ యాడర్కి క్యారీ ఏం లేదు కదా. ఓకే ఏమన్నా ఇది ప్రాబ్లం వస్తే మిగతా మొత్తం ప్రాబ్లం వస్తుంది.
నువ్వు ఫస్ట్ ట్రిపుల్ క్యారీ యాడర్ చెక్ చేయి.
ఓకే అంటే లైక్ ఐ గో ఫర్ ద సిమ్యులేషన్ డైరెక్ట్. ఈ విండో ఓపెన్ అవ్వాలంటే లైక్ విల్ హ్యావ్ ఎర్రర్స్. సో ఇది ఐ థింక్ ద టోటల్ ప్రోగ్రామ్ ఈజ్ ఇన్ స్ట్రక్చరల్. RCA is using structural using full adders. Errors are there. ఎర్రర్స్ అయితే లేదు. ఈ విండో వచ్చిందంటే ఎర్రర్స్ లేదన్నట్టు. కోర్స్ కాన్స్టెంట్ దీస్ ఆర్ నాట్ కాన్స్టెంట్. హెక్సాడెసిమల్. హెక్సాడెసిమల్ అంటే ఐ థింక్ అంతే కదా మేడం. హెక్సాడెసిమల్ విల్ గివ్ 3 ఇస్ నథింగ్ బట్ ఇట్ ఈస్ గోయింగ్ టు యాక్సెప్ట్ లైక్ 4 బిట్స్.
0011.
ఎట్లా అంటే 0011. ఓకే చిన్న వాల్యూస్ ఇద్దాం చూద్దాం. 4 carry initial carry as 0 is it 1
ఓకే ఓకే.
చూద్దాం 0
7.
I think for 10 microseconds. No intermediate carries. I think నేను ఫుల్ యాడర్ అక్కడ చెక్ చేయనట్టున్నాను మేడం. ఒకసారి కెన్ ఐ గో ఫర్ సోర్సెస్. ఐ విల్ రీప్లేస్ మై ఫుల్ యాడర్. చూద్దాం. యాడ్ సోర్సెస్ మ్యామ్ ఫైండింగ్ ఎనీవేర్. రీప్లేస్ ఫైల్. Replace file, that is first full adder. Okay this is simple ma'am. Some AX or BX or C. This is good. So run simulation. Yes. ఎక్కడో అది కరెక్ట్గా చూడలేదు. అప్పుడు కూడా ఏదో ప్రాబ్లం వచ్చింది స్ట్రక్చర్లో వేస్తే ఫుల్ యాడర్. I think I just changed the full adder logic instead of given by structural, I just given by data flow. అంతే కదా మేడం. Force constant, it's a 4. Force constant, it's a 3. Carry as 0. Then run for 10 microseconds. I got it as SS7. Intermediate carries, so we'll change here the value of B. Force constant sum. Then could not force. Okay, sorry, A కదా. Hexadecimal A కదా మేడం.
Yes, A to F.
స్మాల్ ఏ ఓకేనా?
చూడు.
మళ్ళీ దానికి ఏమన్నా వస్తుందో చూద్దాం. Run for 10 microseconds. I think A is 10 plus 4, 14. E. So this is the option for zoom fit for getting all the input combinations, which I think I just given only 2 combinations, 4, 3, 7. It's carry 1 ఇద్దామా నెక్స్ట్ కేస్. F వస్తుంది. Carry 1. Okay, run for 10 microseconds. F. I'll zoom fit. ఎంత F వచ్చిందా? It's a 10, 4 plus 1, 15. ఓకేనమ్మా. ఓన్లీ అక్కడ ఫుల్ ఆర్డర్ ఐ థింక్ ఐ డింట్ చెక్. అప్పుడు కూడా ప్రాబ్లం వచ్చింది స్ట్రక్చరల్, అందుకనే ఫుల్ ఆర్డర్. సో ఇఫ్ ద సబ్లాక్ విచ్ యు ఆర్ ఇంక్లూడింగ్ ఫర్ యువర్ top level module to design, if anything is someone is asked yesterday, we need to check for each and every is nothing, but it is better to check all the blocks which you require to design your top module. If all are okay, please try holding control and press key and zoom. Okay. Kriti Shreya, she is given some. It's control and press key. So try it, Dhamma. Control. What? ఏమేమి మేడం ఏదో చేసిన ఏదో ట్రై చేయమంటారు. ఇదేదో ఓకే. ఈ విండో ఎక్కడ? Ma, is it okay? Like we are done with the buses. How to include the bus structure? If more number of inputs will be there, like instead of including one by one, you can even use buses. But to access that buses, the inputs are input followed square braces followed by your index. Can be 0, 1, 2, 3 according to your like bus strength. Okay, ma'am. Any doubts, pa? Hello?
Hand over to Mahendra sir, Aruna.
Oh, sir joined. Okay. I didn't see now. Stop sharing. I will. Hello? Hello, sir. I think sir is set up.
Hello, are you able to hear me?
Yes, sir.
Thank you. Actually, today I'm using my laptop. It is a bit slow. Okay, you have to bear with me.
Okay, sir.
Very good afternoon. I hope everybody is doing good, and I hope understood and practiced all the tasks whatever we given. Today there will be some more tasks. Why? Because during these 2 hours we will give you the knowledge, okay, how to handle the tool and also information about the Verilog HDL. Then we are giving the tasks to you to practice it and understand more. And if you have queries, you can post it and we will help you. Okay, that's not a problem. But if you practice all the tasks, whatever we are giving, definitely you will get the enough knowledge to handle with the Verilog HDL. Okay. Naruna ma'am,
Sir. Sir,
can I?
I just done with the ripple carry adder
Yeah,
structural model
great.
using 4-bit the 4 full adders.
Hmm.
Like
That's
I'm
the
asking,
same. How we have done by using half adders, full adder. Now for the ripple carry adders, we need to interconnect 4 full adders. Same concept. But for discussing all the tasks, whatever I given you in the sessions, we don't have much time. That's why I given you the tasks. Since you have understood the structural modeling, everybody can do that also. Am I right? With that intention only, we are giving more tasks to practice.
it is not two-way session, sir. It is only one way. We are even asking. Only very few are giving the replies.
Yeah, that is happening. Yeah. I don't know whether they are interested or not, or for the namesake they have joined. Anyway, means two things we can assume here. One is they're understanding everything and they're practicing everything. Another one is they are just participating. Anyway, that is up to them. Anyway, we are spending our time and we are giving our knowledge. Taking the knowledge is depends on other part. Anyway, today is the last day. Okay, we will do some remaining concepts today, so that will help you to understand in-depth concepts of your like HDL. Okay. Now, for half an hour, we will discuss some of the operators and constructs for behavioral modeling, and then we will have the practical session. Is it fine? Anyone unmute yourself? Anyone participant, and then tell me what we have learned till now. Means 2 days passed. Okay, and I given you tasks. If you are interested, just to speak out what are the concepts you have learned till now, I am very happy. Any one participants unmute yourself and then tell me what are the concepts we have studied till now. Just I am asking you the concept names. I am not asking to explain the concepts. Is my voice is clear? Aruna ma'am,
Yes, sir.
my voice is clear now.
Yes, sir. Yes, sir.
Yeah, thank you. Anyone, please unmute yourself and then tell me what are the concepts you have learned till now.
So using data flow and gate level description languages, we have covered combinational circuits and even basic gates. We
Basic
have,
gates and yeah,
yes.
thank you. We have studied the VLSI design flow, and then we have seen some constructs what we can use in like HDL, and then we have designed the digital systems by using two coding styles or two uh, description levels. Okay, that is the data flow modeling and gate level modeling, or data flow modeling, structural modeling. Okay, that gate level modeling also can be called as structural modeling. Now I hope all of you understood the concepts and able to do the tasks. If you do all the tasks, you can get the enough knowledge. And then Google is there for more information. See, here we give you basic information which is necessary to understand the in-depth concepts. Now, after knowing how to handle the tool and the basics of Verilog HDL, then you can understand whatever is there in the Google. In the Google means if you type Verilog, you will get so much information. But you should be in a position to understand. But I hope now you are in a position to understand what are the programs written in the Google, and then whatever program you wanted to simulate, you can copy it and understand, and then execute it by using the tool. Okay, that is what main agenda of this one, to enable you towards the basic concepts of Verilog HDL and also give the hands-on practice on handling the tool. Now I hope everybody familiarized with the tool. I think so. Anyone unmute yourself? Tell me, have you familiarized with the tool or not yet? No one wanted to speak. Yes, Ramesh. Yes. Yeah. Thank you. Now let us understand a few operators what we use, and then we'll understand the behavioral concepts. Okay, behavioral coding style. That is also another important style. Okay, and that is not another. That is most important style. Why? Because most of the cases you cannot understand the architecture of the digital system, or you cannot put the applications in the form of uh, digital systems. Okay, so if you write the behavior in terms of HDL, then that behavior of HDL code can convert that into the gate level netlist. Okay, that is possible. That's why this is very important. And without the much knowledge about the digital systems, you can design the digital system for the application. And that is what the beauty of this behavioral level modeling. That's why it is having the highest priority in Verilog HDL. Okay. Now, can I share my screen? Are you able to see my screen?
Yes, sir. Sorry.
Speak out, ma'am.
Uh, uh, yes, sir. Yes, sir.
We have not yet discussed these concepts, I hope, right? Lexical conventions, data types, right? Just we will have what are the lexical conventions means vocabulary. As I said, English language having the vocabulary, Telugu language also having the vocabulary in the sense the mix of words which we can use to convey our feelings. Am I right? Same way, Verilog also having the lexical conventions. That is what constructs we can say. Okay, like all the lexical conventions can be called as constructs. Okay. Now let us look at the operators, lexical conventions, data types, and scalars vectors. Already you have gone through some of the concepts, but anyway, I will give you means little knowledge within 5 minutes about all these things, 5 to 10 minutes, and then we will see the operators. After that, we will go for the behavior level modeling. Now, identifiers, already I said, identifiers are the variables used in the Verilog HDL. Okay, all the names, whatever names you are giving, module name, variable names, data types names, okay, everything is comes under. Strings already you know. If you keep some information in the string, in double quotation, that will be string. But here, thing what you need to consider is the white space. White space also considered as one character in the string, and each character takes how many bytes to store? 1 byte. Like that, if there are 5 characters, if you look at this special example, here you can see only 3 characters, but there are 2 white spaces. Okay, that is what we need to understand. Okay, while writing the strings, Verilog HDL consider the white space also a character. Except this place and white space is having nothing meaning, but that can be used for readability. Okay. Now let us go to the next keywords. Keywords all are the purple color, what you could see in the tool. Those all are the keywords. Okay. Now keywords are reserved words, and we should not use these keywords as the identifier name. That means if I ask you to write Verilog program, and after the module, if you want to give the module name, Okay, module name cannot be given as NAND. You see here, NAND is keyword. You should not give name of the module as NAND. That means we should not use these keywords as the identifiers. These why? Because these all are reserved, like C language. In C language also, no one allow us to verify or to use the keywords as the identifiers. Now this is one example. Okay, all red colors are keywords. I don't spend much time on this. And here I wanted to spend some time. And you will be seeing 1B0, like that we will be assigning the values, initial values. In the test bench also, we are not assigning only 0 and 1. We are assigning 1 tick B0, right? Now that is because of there is some specifications we need to follow while representing the numbers. That is this, right? Size, how many bytes we are using. And if you write the test bench for the ripple carry adder, what you have seen, their input size is 4-bit. So you have to give size of the data is 4. And base is, if you are following the binary, you should give the B. If you are following the decimal, you should use the D. If you are following the hexadecimal, you should use H, octal O. But octal we will not use here. We will be using binary or hexadecimal in most of the cases. But anyway, so this is the syntax what we need to follow. Are you able to see my screen? Why? Why? Because I'm asking you. Okay, my laptop
Yes,
is
sir.
digital. That's why
It's
whether
going.
it is coming to you or not, I want to know. Okay, that is why here this is the concept what we follow. 4B, 4-1. So because size of this is 4. And a 12H. Each character or literal in the hexadecimal takes 4-bit. That's why here there are ABC are the hexadecimal values. And each takes 4-bit. That's why 12-bit. Right? And a decimal and hexadecimal takes 4-bit and octal takes 8-bit, sorry, 3 bits, and binary takes only 1 bit, right? And here first one is always size, tick the base, then value we will assign. This is what. And here another thing we need to remember, whenever you are representing these unsigned numbers, no need of putting the sign here. Okay, whatever you write that will be considered. Without this 4B, if you don't put 4 tick B, if you write the triple one, 4 1s, this Verilog HRE understands that as the decimal. Okay, if you don't specify the base of the data, defaultly that will be taken as decimal. But most of the Verilog constructs will not accept the decimal as it is. They accept only binary. That's why there is need of representing the base also very clearly. Okay. Now here special cases, whenever you are representing the negative numbers, you need to use the sign minus. So minus 6 tick D3. That means this value is negative minus 3. That's right. That minus should be kept here. Otherwise it is illegal. Okay. You should not put here. These two examples we given. Always minus should be kept here. But while storing this in the Verilog HDL or while reading the Verilog code, it takes the 2's complement of 3. Takes the 2's complement of 3. Okay. Now that is one thing you need to remember. If you want to give the negative numbers, why? Because you will come in the future across where you need to give the negative values as the input. Whenever you want to give the negative values as the input, simply you can give minus 3. If you give minus 6 D3, that reads the 2's complement of this. No need to convert into 2's complement and then give as the input. Just you can use the minus symbol. Automatically that will be converted. Next point what you need to remember is, see here at times size of the size of the number will be high, but value what we assign is less. Suppose you take here 1B, if I have written only 1B only down if I write, and there will be 2 positions will be vacant, and those 2 positions will be filled with some MSB. There are some rules here. If that is X, MSB is X, X will be filled. If that is Z, Z will be filled. Otherwise, 0 will be extended. But if the number is that is negative number, assigned representation, then the MSB of that number will be extended. If that is signed, MSB will be extended. If that is unsigned, 0 will be extended at the MSB places. Okay. Now that you need to remember. Here you need to remember three things. Okay. One is the format what we use. Second one is for the negative numbers we can use the negative. And if there is a higher size and a lower value, and then that lower value will be equated to the size by putting dummy values at the MSB, and those dummy values will be extension of the MSB sign or zeros. In the case of sign negative numbers or sign numbers, MSB will be extended. In the case of unsigned numbers, zero will be placed at the MSB, vacant MSB positions. Okay. Now this is one example how it is done. Now look at this. Here 14 we kept size, but 1, 2, 3, 4 only given. But while displaying it, it takes 4 zeros. So because this is unsigned. And here you can see minus 32. Since that is sign, okay, that will be displayed as 2's complement. Now look at this. This is first, second, third. Okay, third will be displayed. This is fourth one is a equal to minus 32. Okay. Now whenever we put the minus, that value what Verilog HDL loads is 2's complement of that one. Same here also. Second case also. 1, 2, 3, 4 we are giving as input, but Verilog HDL reads 2's complement of that as the input. Okay. Now this is what here we given 1, 2, 3, 4 only, but size of this is more. That's why here 4 more zeros are placed. I hope you understood how to represent the numbers. Now let's move to next. Now as you know, Verilog HDL considers only 4 types of values: 0, 1, X, Z, where 0 is logic 0 or false, 1 is true, logic 1, and X is unknown, don't care. Okay, Z is floating. Floating means no connection or high impedance. If there is no connection, automatically that leads to the high impedance case. Okay, now these are the 4 logic values what we use, right? And there are 3 kinds of operators. Unary operator, that means operations will be happening on single operand. Operand in the sense inputs. In layman language, I can say operands is inputs. But in coding language, operands are the variable on which operations are happening. Okay. So here there are 3 kinds of operators. Unary operator performs the operations on single operand. Binary operator performs the operations on double operand or 2 operands. Ternary operator performs the operations on 3 operands, right? Ternary. That is why unary means 1 operand. Binary, here 2 operands will be involved into the computation. And in ternary, 3 will involve into the computation. Now for this is the best example. You can look at the example. Now here there are 2 inputs. This is again behavior of the multiplexer we are describing here. Means in most of the cases I will be taking multiplexer only as example. Why? Because we can explain the same concept with the different styles. Okay. Now here first 2, output 1, output 2 are just first one is unary. Here negative. Okay, negation symbol is the unary operator. Okay. Now end operation, logical end operation is performing operation on 2 operands, that is input 0 and input 1. Now if you look at the data out 3, and it is used the ternary operator. Ternary operator. At times we can call this ternary operator as conditional operator also. Here there are 3 operands you will involve. 3 operands means first verify the B. If B is true, C is assigned to A. Else D is assigned. That means these are the 3 operands. B, C, and D. These are the 3 operands which involve in the operation. That's why it is ternary. Now here it verifies select line. If select line is 1, data in 0 is assigned to output 3. Otherwise, data in 1 is assigned. Okay. Now I hope this you understood. And here there are some strengths. These strengths are used for specifying the driving strength or storing strength of the value. Driving strength and storing strength of the value, but you no need to worry much about the strengths. You have to understand, remember only values and the operators and how we write the programs by using the operators. Now these are the 3 concepts what you have to understand in this slide. Now let us look at the data types. Already we have seen few of the data types, but here I am describing what kind of data types we use in Verilog HDL. In generally, two types of data types we can use in Verilog HDL. That is net type. Second one is variable type. This net type cannot store the data. Okay, that always represents the physical connection between the structures. Wire, try, supply 0, supply 1. These are the examples for net type. These are the examples for net type. And syntax is already you have seen. Okay, data type in some of the while reading the test bench we have written clearly. Okay, wire signal name, reg signal name. Same here also. Okay. Now here data type will be net. Net means we can use wire, try, supply 0, supply 1. These all are non-storage elements. Okay, whatever you see here, these are the non-storage data types. But here, variable data types are the storage. That means net does not have the storage. This just pass the information or carry the information between the modules. But variable data type stores the information. And the examples for variable data types are registers, integer, real, and type. Register, integer, real, and type. These are the four variables, and these variable data types stores the data. That's why wherever you wanted to store the data, there we use reg, not wire. Wherever you want to just pass the data between the modules, there we use the wire. Here most of the cases we use the wire or reg or net. Now see a few examples here how to define reg. This is 1-bit register. Okay, wire means simple, carries the information, while w1 w2. Even in reg and wires will have the range, width, bus width. We can say this as the buses, okay, or vectors. That is what the concept of scalar means single bit, vector is multiple bit. Vectors can be represented by specifying the range for the data types. Now these are the few data types what we use, but here what you have to remember is wire and range. These are the two data types widely we use in the Verilog HDR. Wire and range. Wire is used for the interconnections, range is used for storage. Now let us look at the scalars and vectors. Scalars are single bit data types, vectors are multi-bit data types, and you have understood how we can define the multi-bit by simply specifying MSB and LSB. Okay, MSB is the most significant bit, LSB is lowest. And if these both you can interchange also. Instead of LSB, here you can write LSB and here you can write MSB. But if you write this, the left hand side one will be the most significant and this side is less. Now this is one example. And here we need to find some important points. And this range will be either positive or negative. Now here in this example, in first example we have kept 3 down to 0, 3 to 0. That means it is taking the adder, takes the 4 bits. Names for this is adder in bracket 0, adder 1, adder 2, adder 3. MSB is adder 3, ADDR3 is the MSB. It's not adder, it is address actually, but in short we have written ADDR. ADDR2, ADDR1, ADDR0. But whenever you come here, you look at the second example, wire -3 colon 4. That means it starts from -3 to 4. That means -3, -2, -1, 0, 1, 2, 3, 4. Total how many? 8 bits. Okay. Now this is another example. You can define the multiple data types under the multiple variables under the single data type. Now look at this example. This is the example of 4:1 multiplexer. By using the operands, that is ternary operand, and the concept of scalars and vectors and data types. Right. Now look at this outputs. Here we have not written simple output. Here I have added the one data type, that is reg. Whenever you put the reg, that indicates that this output variable, that is data out, also stores the data. Normally inputs outputs just pass the data. That means they are net type in general. But if you want to make them as the storage type, then we can define the data types for the output also. That means for the interfaces also. So that one register will be attached to that. To the pin, there is one register internal attached to store the data which is passed on the output data output. Okay. Now this is example for 4 to 1. Now data out equal to, see here, ternary operator is used. Compared SEL. SEL is the select line, right? And data in 4:1 multiplexer, there are 4 inputs and 1 output, and 2-bit select line is required. Now here you can see input is defined with 3 down to 0. That means data in is 4, data in 3, data in 2, data in 1, data in 0. There are 4 inputs and 2 select lines. Now if those 2 select lines are 0 0, now look at this. Here we have followed the standard of representing the numbers as I explained you just before. Okay, 2b 0. Okay. Now here question mark indicates, as I said, in the unary operator. First, this will be compared. If this is true, C will be assigned to A. If it is false, D is assigned. Same way here also. Look at this. Now SEL is the select line. Okay, if that is 0 0, data in 0 is assigned to data out. Question mark after that, this will be assigned. Else, after the colon, whatever statement we write, that is the under else. Inside that, we have kept again comparison. That is nested comparison we are doing here. If this is true, then data in 1 is assigned to data out. Else, again comparison SEL with 1 0. If this is true, data in 2 is assigned. Else, again verified this one, and that is true, this is assigned. Else, finally default value. If the 4 are not true, then floating indicates that Z, high impedance. Okay, high impedance is assigned. Now here you can see, here we kept only Z, but here size is 4, so here it is the Z, so Z will be extended for remaining 3 bits also. Okay, so 4 Z's will be assigned to data out. Why? Because data out is 1 bit. Now here it is not 4Z. 1 minute. It should be 1Z. Why? Because data out size is only 1 bit. Now to understand how do we use the operators, scalars, everything. Now these are the few examples what I would like to give you, and also some taxonomy what we can follow in Verilog HDL. Okay. Now here we have seen the lexical elements and the logic values, operators, and the data types, scalars and vectors. Scalars are single bit, vectors are multiple bits. Now let us see more concepts before going to the practical session. Now let us look at the different operators what we use in Verilog HDL. Different operators what we use in Verilog HDL. Now operators, in the sense, operators performs the operations on operands. Right? One operator we have seen are some basic operators, that is unary, binary, and ternary. We have seen. What is unary? Performing operations on single operand. Binary, performing the operations on 2 operands. Ternary, performing the operations on 3 operands. Now let us see more operands what we use in Verilog HDL. To perform the arithmetic operations, we use These are the operands. Here you can see the table. In this table, we have explained you the symbol what we use for the operation and the functionality of that symbol. Okay. For performing the addition operation, we use the plus symbol. For performing the subtraction, we use minus. To perform the multiplication, we use asterisk. To perform the division, forward slash. To perform the modulus, percentage symbol. To perform the exponent, exponent means two times multiplication. That's why two asterisks. Now these are the symbols what we use to perform the arithmetic operations. And here few points what we need to remember is carry bit. If size is enough to store the carry, that will be stored. Otherwise, carry will be lost in most of the cases. Now these are the examples, and now look at this. Now this is how we write the program. Okay. Now here, if you want to perform the addition operation, this is how we write y1 equal to a plus b. And here we kept all these things in the always statement, always construct. This is the procedural block in Verilog HDL. Always is procedural block in Verilog HDL. And whatever statements we write inside the always procedure block, all are sequential. In general, all the statements what we write in Verilog HDL are concurrent. But if we write these statements inside the always block, all those statements will become sequential. Sequential in the sense, one after another will be executed. Okay, we don't have much time to spend on this, just have the glimpses of this. And if you want, you take the snap and store in Word document. Next, bitwise operators. Now this is very important. Why? Because most of the operations what we perform is logical operations. Now here we cannot call this AND, negate, or cap is XOR as the logical operators. We can call them as the bitwise operator. Why? Because these operators perform the operations on individual bits or pair of bits, not on the all bits at a time. Okay, it performs the operations on bit level. That's why we can call them these operators as bitwise operators, and use it to perform the all logical operations between the bits or between the uh, pair of bits. Now you can see some examples here. Now this is how we write the program simply. Since all the this is unary operator, these are all binary operator. Binary operator means there should be two operands. For the unary operator, there is only one operand. Okay, that's why here you can see. Now, if you want to perform the NAND operation, how will you perform? Can someone unmute yourself and then tell me? Now here there is no operator for the NAND. How will you perform the NAND operation? Hello, I'm asking you a question. Can someone tell me how will you perform the NAND operation? Yes, please. Hello, are you with me? Just I'm speaking.
Sir, someone is responding in the chat box.
Okay, but actually while presenting, I cannot see the chat box. That is what drawback. Yes, great. Kodesarao garu. Now we have to use the combination of negation and. That is what. Here you could see in the example, I have kept this symbol. Okay, that also can be used. But you may get confused. That's why I'm changing it now. This also can be used. Now look at this. If you want to perform the NAND operation, that is negated AND. AND operation, whole will be negated. Negated OR, that is NOR. XNOR, negation of this. Here you can put the here or here. This also you can put here, no problem. Okay. Now this is how we do bit level operations, and these are the operations most probably we can put in the data flow modeling. In data flow modeling, we have to represent the digital system in terms of its Boolean equation, and Boolean equation will be having almost all logic operations only. Okay. Now next, the logic operators what we have seen previously can be used as reduction operators also. Used as reduction operators. Reduction operators in the sense, this is performing the AND operation on single operand. Okay, single operand. That indicates that AND operation between the logical bits. That means now if it always starts from the LSB 0 ended with 1, then result is 1. This result is ended with 0, then result is again 0. That result is ended with 1, result is 0. So output is 0. That means these reduction operators can be used to reduce the vectors into a single bit. If we want to reduce the vectors into a single bit, we can use these reduction operators. These reduction operators are nothing but the bitwise operators, which performs the logical operations on the individual bits. So if you want to use them as the reduction operator, this is how we can write in the program. Y1 is the output, simple AND symbol and A. AND symbol and A. But there is need of two operands to perform the bitwise operation. To perform the reduction operation, reduction means same variable we are reducing from vectors to the scalar, vectors to the single bit. So this operation will be performed on single operand. Okay, same for NAND. If you want to perform the NAND between the individual bits of the variable, this is the example for R, NAND, NOR, okay, XOR, XNOR. Now this is how we write the program also. Same here, means for all the examples I am following the same kind of programming, but here I am explaining you how to put the constructs effectively in order to perform the operation. Okay. Now next, equality operators. This is important. Now these equality operators are used to compare the operands. Compare the operands for its equality. Now at times whenever you are describing the behavior of the system, if you are following the data flow model, no problem. There will be a Boolean equation. We can implement that directly. And if you are following the structural coding style, then also no problem. Why? Because there will be structure known to you, and you will be interconnecting the logic gates to get the behavior of the system. But whenever you are describing the behavior of a system, then there is a need of verifying the conditions or verifying the operators whether they are equal or not. Based on that, you will be taking the steps. That means we need to represent the behavior in terms of algorithm, and that algorithm may have the concepts of comparing one with another. Right, that can be done by using these equality operators. Right, for equality, double equal. For not inequality, okay, this is the symbol, negate and then equal symbol. And here you could see two more, case equality and case inequality. Now difference between this normal equality and case equality is case equality will consider the x and z also. X and z also will be considered for the comparison. But this case inequality is not synthesizable. Not synthesizable means practical implementation of case inequality is not possible. That is limited to the simulation only. That is limited to simulation only. Okay, did you understand what is the difference between equality and case equality? Case equality considers the x and z also for the comparison. That's why here, if you are comparing B and C here B is 110, C is 01x. While comparison, it is producing unknown results. It is not producing the right results because X. But if you want to do that through equality, we can get the clear values. But these kind of values comparisons are invalid. Okay, now this is the example for that. Now we can use directly compare, and output of this comparison is logic 1 or logic 0. Logic 1 means true, logic 0 is false. If we compare both of them, if we are comparing them for the equality, if both are equal, 1 will be the returned value, or 0 if not equal, 0. But inequality, whenever you are using inequality, 1 if both are unequal, if both are not equal. If both are equal, 0. Now directly that can be kept in the y1 and y2. Otherwise, based on the that we can take the decision if the another constructs can be used in behavioral modeling. I will explain you later how to represent it. Now this one, if a equal to b, a is stored to y3. Otherwise, b is stored. Now this is another. If you want to take the decisions, then this one. Just if you want to take the equal or unequal decision, then you can simply put like this. If you want to take the decision and then if you want to perform some operation, then we can you go for the third statement model. Okay. Now next kind of operators are logical operators. Now you can see here we have seen the bitwise operator and then reduction operator, and here we are seeing the logical operator, but all performs the same kind of operation. Same kind of operation means logical and logical are logic gates operation, but these logical operators are used to perform on the expressions, and return the value 1 or 0, return the value true or false. But those bitwise operations are performed the logical operations on the individual bits and then return the result of the logical operation. But here it performs the logical operation, then logical operation on the expressions and then returns the true or false. And this is also one kind of the comparison statements. But in the comparison statements, we find equal and unequal. But here we can find the expression is true or not. Okay, now for using this logical operator, this is the example program. Here, if a equal to b and c greater than d, if both are true, then for representing both are true, we use the AND. We use the AND to verify the two conditions are true or not. Now this is one condition, this is another condition. If you want to verify both the conditions are true, then we can use the AND. Or both the conditions are true or false, again here OR operation. Like this, we do apply the logical operators in Verilog HDL. Now, this is the one example for how to use the logical operators and where to use the logical operators in Verilog HDL. Okay, now I hope you understood this, and let us move to the next. Next, this is the relational operator. If you want to compare not only equality, if you want to compare greater than, less than, or greater than is equal to, less than or equal to, then we use these symbols. These are another kind of operators. Greater than, less than, greater than or equal to, less than or equal to. Now this is the program example. What we use. Okay. Now directly, and result of this comparison also, zeros and ones. Based on that, we take the decisions. Okay. Like here, if a greater than b, then the decision is y4 equal to 1, else y4 equal to 0. Now these all are relational operators, especially used in behavioral description. That's why now I am explaining you. Okay, the operators which are used in behavioral description. Now shift operation. If you want to shift the bit location towards the left, right, logically and arithmetically, these are the 4 kind of shift operations we do. Logical shift, shift left, logical shift right, arithmetic shift left, arithmetic shift right. Here difference between logical shift and arithmetic shift will differ in right shift operation only. During the shifting, just visualize the shifting of the bits. If you shift the data from right hand side to left hand side, we can call that as left shift. So LSB positions will be vacant. I hope you understood the same concepts in C language also. Okay, LSB bits will be vacant, and those LSB bits will be filled with zeros, and MSB bits will be lost. Whenever you do the shift operation, automatically whatever data is shifting out will be lost. And since some bits are shifting left, there will be some vacant positions at the LSB, and those LSBs will be filled with zero in both the cases: logical shift left and logical shift right. Sorry, arithmetic shift left. And logical shift left and arithmetic shift left. In both the cases, LSB becomes empty, and that LSB is stored with the zeros. In the case of right shift, that filling the MSB. See, whenever you do right shift, LSB will be lost, but MSB become vacant. Whenever MSB become vacant, then there is the need of carefully filling the MSB bits. Why? Because if that is signed operation, and if you fill the MSB with zero, that sign negative value becomes positive. That should not happen. Negative value should be remain negative. That's why while filling this, the MSB bits in the right shift, we follow. If that is logical, then we fill that with the zero. If that is arithmetic, then if that is unsigned, filled with the zero. If that is signed, filled with the sign bit of the value. Sign bit of the value. How will you differentiate signed and unsigned? MSB. Okay, that sign bit will be placed in all the MSB positions. Now that is the difference between logical shift and arithmetic shift. If you want to preserve the sign bit of a number while shifting operations, then always you can go for arithmetic shift. Otherwise, both logical shift and arithmetic shift represents the same kind of operation, except the signed number shifting. Okay. Now this is how we do perform. Now here you have to remember another thing. Now shifting left and right can be represented by using these operators, but how many bits to be shifted left and right also should be represented. Otherwise, that shifting will happen only once and then stop. But in general, we need to shift that multiple bits. Okay. For that, this is the format what we can follow. Okay. Now you look at this. Whatever data to be shifted, that will be first, and then operator we use. Operator indicates what kind of shift operation we need to perform. After this, we will be specifying how many bit locations. How many bit locations we need to shift. See this example also here also. A shifted towards left hand side by 2 positions. That 2 positions number will be written in the equation. Same here also. Here B is written and B is stored with 3. So we are shifting the A towards left hand side, in this case left hand side, by 3 positions. In this case, you are shifting this towards right hand side by 3 positions. Okay. Now this is how we write the programs by considering shift operations. And miscellaneous operators what we use. And already we have seen this is conditional test, that is ternary operator. Okay. If the statement is true, then true value will be assigned, false value will be assigned. This is one example what we have seen with the help of the multiplexer as example. Okay. At the time of explaining the unary, binary, and ternary operators. Now let us look at concatenate and replicate. Concatenate operator can be used to merge 2 signals. If you want to merge 2 signals or 2 operands together, then we use the concatenate operator. This is also one of the important thing. Why? Because while writing the programs, you wanted to expand the bus width. Bus width means you have to merge 2 buses as a single bus. That means 4-bit bus can become as 8-bit if you merge that with another 4-bit. Otherwise, you replicate it. Replicate means make the double size double. Okay. For replicating, we use this flower brackets. One set of flower brackets for concatenation. 2 set of flower brackets for, 2 set of flower brackets for replication. Okay. Now this. The example here we have used the both. Now this portion indicates the replication. Now this portion indicates the concatenation. Okay, and this complete portion is concatenation. Concatenation of A, B, duplicate of C, then another row. extra operand. Now here A, B both are merged together, and this complete is merged with the replicate. That means C is made twice, and this complete is merged with another one. So its size is 15 bit. 14 down to 0 means 15 bit. But individually, each size is 3 bit. Each size is 3 bit. Like that, 1, 2. Here, this is replicated twice. So 4, 1, 5. 5 into 3. Each having 3 bit. So 3 bit. So total 15 bit Y size. Now see here. Here Y is formed by merging the different operands together. Now this kind of operations required in Verilog HDL also in order to resize the buses. Okay. Now this is one example for that, and the same here you can see another example for the conditional test. One example we have seen by multiplexer behavior. Now here you can see timeout. Now I wanted to compare the real time with timeout. Timeout. If that is not true, then timer will increment. If that is true, then restart the timer. That is the behavior here. Here we have designed a stopwatch. I can say this is the program for the stopwatch. Stopwatch means we can set the timeout. So that is the timeout. Now we start the timer. If the timer is not equal to timeout, then timer will increment. If that is equal to the timeout, then reset to 0. That is what the behavior. Now if you want to design a clock, that is stopwatch. This is the program for designing the stopwatch. Same concept. Okay, now these are the few operators what we have seen. We have seen the arithmetic operators, then bitwise operators, reduction operators, comparison operators, that is equality operator, logical operators, and relational operators. In the final shift and miscellaneous operators we have seen. Now these are the operators what we use. In summary, I can show all these things. These are the complete operators what we can use in Verilog HDL. Bitwise operators, reduction operators, arithmetic operators, concatenation operator, duplication operator, shift operators, bitwise operators, equality operators. Now this is the summary of all the operators what we could use in Verilog HDL to describe the behavior of digital systems. Okay. Now I will stop with this here. Now let us see some programs.
Sir, one question is asked in the chat window.
Mm-hmm.
In case of
Negative
arithmetic,
is negative
left shift sign is not maintained.
1 minute. Negative is negative only. In case of arithmetic shift sign is not. Sign is mentioned with the 2's complement of that. Whenever you do the 2's complement, that sign MSB will be 1. So MSB will be extended throughout. Arithmetic left shift. Okay, we are speaking about the arithmetical left shift. In the case of arithmetic left shift, what happened? MSB will go out. Okay, so MSB now becomes nullified in the case of left shift, but in the right shift, MSB will be remain. Okay, that is why that will happen. Why? Because whenever you shift, no, that you automatically left shift always makes the multiplication operation by 2. Are you getting what I am speaking? Zakir Hussain. You can unmute yourself and then you ask me exactly. Just look at this. Vacant positions will be at LSB in the case of left shift. So MSB, that is sign bit, will go off automatically whenever we shift. So no need of representing the sign. Yeah, what you said, that is right. Okay, in the chat box you said that negative and positive. Okay, during the division and multiplication, that sign should not change. Okay, that is true only. But in the case of left shift, okay, as per the that shift operation, that that only will happen. Okay, here I means we cannot change anything. Why? Because they made the structure in such a way that whenever left shift happens, arithmetic left shift, then that sign bit will go off. So they have not said to fill the sign bit at the LSB. Why? Because we cannot fill the sign bit at the LSB. Why? Because whatever left out, that will be left out only. But in the case of right shift, there is chance of preserving the sign bit in case of right shift. But in the case of left shift, there is no possibility of preserving the bit. So whatever leftmost bit, that will go off, and vacant will come at the LSP. Okay, that is what the concept there. But there they cannot consider this whatever logic you are kept here. As of my knowledge, I can say that one. Okay, but we need to see in depth. Okay, somewhere they might have given some solution to this. Anyway, I will let you know. As of now, as per my knowledge, that will happen. I'm just explaining the shifting operations. But there, we are not thinking much about the sign bit is preserved or not preserved. But in the right shift, there is possibility of preserving that MSB. That's why there is preserving. Why? Because if they fill the MSB with 0, then negative becomes 0, positive. So they have preserved. But in the case of left shift, there is no chance of preserving MSB. Why? Because MSB is going off. That is, sign bit is going off while shifting, and we cannot preserve that by filling that at the LSB. That's why LSB will be filled with 0 only. But whatever logic we kept here, we have to see some cases will be there. Okay, we have to look at that case. Otherwise, we have to avoid the situation of left shift while performing the operations with sign operands. Okay, thank you. Any queries? I will take it up some queries. Now, these are the basic concepts what you have to understand. Why? Because if you know the basic concepts, then you can understand the programs easily. Why? Because all the programs will have the constructs, whatever we have seen, but you need to understand what is the specification of each construct and how to use them. That's why I'm concentrating more on explaining the concepts instead of giving you the various programs. Various programs, anyhow, I'm giving you through the tasks. There you can understand even my absence. Without my presence, you can understand all those programs if you know the concepts. That's why I'm concentrating more on the concepts here. Okay, now let us look at the behavioral modeling. Now we have seen what is the enough requirements to start with the behavioral modeling. Why? Because behavioral modeling uses the many operands and also equality statements in order to keep the behavior of the system effectively in HDL constructs. That's why I have shown in previous two. There is no need of much knowledge about all these concepts, whatever we have seen. Why? Because data flow modeling simply a Boolean equation, and structural modeling we know the logic gates and the interconnection of logic gates gives you structural modeling. But behavioral modeling is not that. Without knowing the knowledge about the Boolean equation and the structure of the digital system, you have to design a digital system just by seeing their behavior. Same kind of means explaining the concepts of theory and explaining the concepts of mathematics. For explaining the concepts of mathematics, if you know the logics, that is that is enough. But explaining the theory, while explaining the theory concepts, you need the communication skills and visibility skills also. Okay, for explaining the mathematics, simply you can write the mathematical equation. You can show that now this is the mathematical relation between the variables. But if you want to explain the same with the theory, then you need to use vocabulary, your language vocabulary. That's why here in the behavioral modeling of Verilog HDL, there is need of vocabulary. That's why we have seen all the constructs what we can use in Verilog HDL. Now with this knowledge, let us start with next one. Yeah, I will tell you. Means I am coming to the always construct only. Now in my next presentation, I will explain those concepts. And now let us look at the behavioral modeling. Now any queries? If you have any queries, I will take it up now. Sai Pranit, I will explain you always construct now. Okay, don't worry about that. Now let us kick start with next concepts, that is behavioral modeling. This behavioral modeling describes the system behavior using procedural statements which control the simulation and manipulate the variables of the data types. That is what behavioral modeling we do. With the help of the behavioral modeling and procedural statements, we control and manipulate the variables of different data types. And here we use the continuous assignments. As we used the continuous assignments in the data flow modeling, here also we use the continuous assignments, but we can call them as the procedural assignments, which can update the storage elements, that is the registers. There in data flow modeling, whatever continuous assignment, that is just a net type. But here in the procedural assignments, procedural assignments in the sense, the construct assignment construct, if we write in the always block, procedure block means always block and initial block, there are procedural blocks. Those continuous assignment statements which are wire type or net type will become the reg type. Reg type means storage type. Now here in behavioral modeling, we use two kinds of procedural blocks. One is initial, another one is always. First one is initial, second one is always. Here initial will be executed only once. At the initial stage of execution only, this initial block will be executed. But always block will be repeated, like while one, continuous repetition. Procedure block is always, that always executes in the loop. That's why that name also always executing construct. But initial construct is only executed at the initial undo and one time only, not multiple times. Now this is the example, and already we have seen this initial in the test benches. While writing the test bench, we have seen this initial procedure block. And here, whatever procedure blocks you could see, initial and always, all these blocks are sequential blocks. That means what are the constructs we write inside the initial and always block? Those constructs are executed sequentially. Sequential in the sense one after another. Same here also. When I put this, first clock will take the data, next reset will take the data, enable will take the data, and then data will take the data.
Hello, is it audible? Hello.
Yes, ma'am. Only your voice is audible, ma'am.
It's audible.
Okay, okay. Maybe sir disconnected. I think any problem with the power, I'll see.
Am I audible now?
Yes, sir.
Thank you. Yes, I was not noticed. Actually, whenever I'm presenting my slides, I could not see these Google Meet screen. That's why I was unable to recognize. I was explaining the concepts.
Hello.
Yeah. Now you're able to hear me.
Yes, sir.
Now are you able to see my screen?
Sir, we'll do one execution.
Right?
Sir,
Yeah.
sir, instead of basics, like we'll go for the sequential circuit implementation using Vivado tool.
Yeah. For understanding means that concepts, we need to know now whatever concepts I'm explaining.
Okay, sir.
Yeah, we'll do that. We will do that soon. Another 5 to 10 minutes. Okay. My participants are asking to do that really quickly. Are you able to see my screen?
Yes, sir. Yes, sir. Maximize, sir.
Yes, I'm doing that. Now,
Yes, sir. Yes, sir.
maximize.
Yes, yes.
Now that, yeah, thank you. Now this is the main purpose of using the always block. Why? Because most of the digital system should work in real time. Real time means whenever there is change in the input, that should reflect immediately. Here, with the help of always block, we can do that. And whatever constructs we write in the always block, that will be in sequential. Arna ma'am,
Yes, sir.
be mute ma'am. I think some noise is coming from outside.
Yes, sir. Yes, sir.
So I hope you understood what is the need of sensitivity list. Yeah. Here R indicates again logical R operation. A or B or SEL. If any one is changed its value, then immediately these all the constructs are executed. If you put here and A and B and cell, if all are changed its value, then only this will be executed. Now here we can put the the events or signals, that is A comma B comma cell, or we can specify the some logic also in the sensitivity list. Now this is the construct what we use for always. Now let us go to the next. Now here you need to understand another statement called case statement. The case statement checks if the given expression matches any one of the other expression. That means if you want to compare multiple expressions, that means if something is true, then one kind of operation. That is not true, another kind of operation, like that. Okay. If you want to compare expressions, multiple expressions, okay, then we use the case statement. Okay. Now this is the syntax of case statement. Case, what expression we wanted to verify, and then the first version of the value of the expression, then second version of the value of the expression, third version, fourth version. Okay, like that we keep on. And if you want to, you see here for the single statement directly we can write. If you want to keep the multiple statements under this particular condition verification, then we use the begin and end. That is in the C language, open bracket, open flower bracket and close flower bracket. Here begin indicates open flower bracket, end indicates closed flower bracket in C language. Okay. Now if you want to write the multiple statements, then we use the begin and end. Okay. Now this is the case statement, and this is one example. Okay. Here we have implemented again multiplexer, 2:1 multiplexer, not 2:1. This is a 4:1 multiplexer where inputs are ABCD, output is out, okay, and select line. And here each input size is 3-bit. Remember here means previously we have taken only single bits. Now here each input is 3-bit, and so output also 3-bit. Why? Because input is connected to the output based on the select lines. So if since input is 3-bit, outside output also should be 3-bit in order to match. Since here there are 4 signals, there should be 2 select lines. Now this is the way. And this case statement is sequential statements. Always we have to use this case statement inside the always block. If you use the case statement outside the always block, that will not be executed. Now whatever construction I have done, that will not be executed in the always block. But because these case statements are sequential statements, so verifying the conditions should happen sequentially. Okay, that's why here it is there. Now here in the always block, always begin. Why? Because multiple statements we are writing in between the always block. That's why always begin and then end. This begin and end. Now case in bracket we can write what is the signal for the comparison. Now here we have to compare the select signal in order to connect the inputs to the output. Now if that is 0 0, output is connected with A. If that is 0 1, B is connected to out. 1 0, C is connected. Okay, one
Hello. Hello. It is not audible, sir. Hello.
Sorry, again I got disconnected. It seems.
Hello, sir.
Yeah.
Disconnected, sir, actually.
Yes. I'm connecting it again. Now, are you able to see my screen? Aruna ma'am?
No, sir. No, sir. I'm not presenting.
Now it is visible?
No. It's visible, sir. Maximize it, sir.
Yeah, I done it.
Yes, sir.
Thank you. Now I hope means I got disconnected while explaining this module. Am I right?
Yes, sir.
Now here thing is, this is the case statement, case construct what we need to use, and here this default must be there. If all these statements are not true, then a default should be there. Okay. Now if you want to use the multiple statements inside each condition, then you can use begin and end. Wherever you want to use the multiple constructs, and after checking the some condition, then we use the begin and end. Okay, keep that in mind. Now next let us look at another conditional statement, that is if else. If statement, if condition is verified, if that condition is true, statement will be executed, otherwise and if else, if condition is true, this statement, else this statement will be executed. Next if else, if statement, else if condition, again statement. Now this is same as the C language. I hope no need to explain much about this. Now look at the behavior of D flip-flop. This is the sequential circuit. Okay, first the sequential circuits are flip-flops. Now just you can see the sequential circuit. Most of the sequential circuits are described by using the behavioral modeling. Okay. Now look at this. Now module D flip-flop. This is the example of D flip-flop. Output is Q. Clock CLK indicates the clock. D in is the D input, and the reset. Reset is required for most of the flip-flops and registers, counters. Now output is Q, input is these three, clock, D in, and the reset, all are single bits. Now here I'm taking Q, that is output as reg. Why? Because output should store the value. Okay, the D flip-flop is kind of storage element, and having the clock so that we can take that as the reg. And one more thing you have to remember, whatever constructs we are placing inside the always statement, all those constructs are type reg, data type is reg. Okay, that means they have capability of storing the values or binary data. Now let us look at the behavior of D flip-flop. You know the D flip-flop output is equal to input. If input is 0, output is 0. If input is 1, output is 0. Same behavior here we can see. Or simply I can say Q is equal to D in. Okay. That when that will happen, whenever reset is 0. Am I right? This is program for the D flip-flop. The same concept you can follow for JK flip-flop as well, T flip-flop, SR flip-flop, everything. Already I will give you. Means, yesterday I might have given you, otherwise I will give you today all the programs for the flip-flops. But here I am showing you one basic example for the flip-flop, and this will be implemented now. Okay. So take this screenshot of this and keep ready, and we'll implement this now on our tool. Always here positive edge. Here sensitivity list will have positive edge. How will you say positive edge of the clock? This is the construct. This PYS EDGE, also a keyword. Always at the rate PYS EDGE, positive edge clock. If you want to make the sensitivity to the negative edge, then here we can add NEG EDGE, negative edge. Okay. And then if reset is 1, here simply if I write reset, that indicates if that is 1, 0 is assigned to DFF. If reset is 1, D flip flop will be reset to 0. Else, if reset is 0, then D flip flop, that is output. Sorry, here the small modification I have done. It is not D flip flop, this is Q. Okay. Output here we have taken as Q. That's right. Now this is the behavior of D flip flop where we have used the if statement. Now we have seen the constructs of initial, always, case statement and if statement. Okay, these are the major constructs what we use in describing the behavior model of digital system. Along with this, there are two loop constructs. Those loop constructs are while and for loop. Okay, this is another example. Okay, for the counter, for universal counter. This is another example by using the fill statement. Okay. Now this is the test bed how to write. Next is while. Now this is one example for the while. Okay, we are running out of time. I hope means I have to stop it quickly. Now while is used for repeating the set of constructs. A set of constructs. So we use the while, and inside the while we will verify the condition. If that condition is true, then this will be executed. If that is false, then this will be skipped. That always this while behavior is same as the while of C language, right? After another construct is for loop. Anyway, I will share these PPTs with you. You can go through it. For loop. This is the syntax for the for loop. For here initial condition we can specify. Okay, that is I equal to 0, I less than, that is the condition I less than n, this is the condition we place. And after that, assignment, that is incrementing the I. Okay, and then begin inside the, after the begin, we write the statements. That means what are the set of statements we can write for the for loop, we can put between the begin and end. Always, if there is begin, there should be end. And if you miss this begin and end, then you will get the errors. Now, this is the behavior of left shift register. Now, look at this. This is the program of left shift register. 1 minute. I will make it more clear for you. Yes. Now here left shift register means that should shift the data towards left hand side. Since here if you take the 8-bit, see here input is 8-bit we have taken, since there is need of passing the data towards left hand side by 8 times. That means first will go off, next like that. Now this is what the for loop we have used 0 to 8. That means that takes 0, 1, 2, 3, 4 up to 7. Total 8 shifts will happen towards the left hand side. That means here if I is 0, 0 plus 1, that means OP1, OP is the output here. Okay, look at this. OP is the output. OP1 will be stored with 0. Now here for the left shift, there should be reset signal as well the load enable. Whenever that is load is enabled, then data will be loaded. Then shift operation will happen. That is the basic construct of the register. I hope you know the register structure. Based on the register structure only, we have developed this program. Here we have described the register by using the behavioral modeling. Okay, now this is another example for behavioral modeling. Now here in this PPT we have seen the D flip-flop, and then register. Registers can be described by using the behavior. Now this is the behavior for describing the shift register, left shift register. The same you can do by interconnecting the D flip-flops also. That is what structural modeling. You can do it by structural modeling as well behavioral modeling. Now here this is behavioral modeling, and you can do the same by interconnecting the D flip-flops also. You can describe the register by interconnecting D flip-flop. Already you might have studied the concepts of shift registers by using the D flip-flops. Okay, same. If you know the structure and you apply the concept of structural modeling, then you will get it. Now, with this, I'm closing the theory part. Why? Because without knowing all these concepts, you cannot understand the programming well. Your concepts are required. If you know the concepts, then you can understand the programs, and then already you know how to use the tool. In last two classes, you have understood enough to handle the tool. Okay, now here we have seen the behavioral modeling. Now, actually, there is need of minimum 1 week, full days from morning 10 to evening 4 to understand each and every concept of Verilog HDL. That is the minimum time required, but here we have the very less time, every 2 hours, that is 6 hours. Even though we are covering most of the concepts, but I am expecting more work from your side. Am I connected? Please unmute anyone and then let me know. Thank you. Okay, now let us understand the design of sequential circuits. Now here we have seen the sequential circuits behavior, and then now we are going to implement first sequential circuit, that is the D flip-flop, by using Verilog HDL on Xilinx Vivado. Now my laptop also a bit slow. Aruna ma'am.
Hello?
Ma'am, are you able to share your screen? So actually my laptop is very slow.
Yes, sir.
Are you able to write the program for the D flip-flop? Otherwise, wait, I will explain the concept. Just let me try. Now, will you stay with us for another half an hour? Let me continue, or tomorrow let us take another 1 or 2 hours if possible. Or you want to close it today? Means I have some tasks to be done for the day, and if you do all those tasks, you will understand all the concepts of sequential circuits. And in between, if you want any clarifications required, and then tomorrow I will take another session. Today, just I will show you how to simulate the clock-based circuits. Since here sequential circuits, most of the sequence circuits will be having the clocks. Now I will tell you how to give the clock signal for testing. No response I could see. Are you ready to spare another half an hour here?
Sir, let us complete today itself.
Yeah, sure. Our organizers will enable you. Okay, I will put the all video recordings. Sure. Thank you. We'll take up to 5. You can share your screen. Actually, my laptop is very slow. Today I don't have my computer. Means I'm at my place because of some problems. I came here. Okay, one of my relatives is not feeling well, so I came here. So I'm delivering the lecture from here itself. Aruna ma'am,
సార్ చెప్పండి.
you can share your screen. Actually, my Vivado is not working on my laptop.
ఎస్ సార్, ఎస్ సార్.
I will share you the program. Just you can put that program. I am withdrawing my sharing. Okay.
Sir, is it visible my screen?
Yes.
It is loading for me. Yeah, it is visible now.
Hello. Create new project Vivado window is visible.
Yes, sir. Now.
Okay, okay. Is it okay, sir?
Yeah.
Next,
Now what are
and
design the D flip flop first.
sir, I'll unmute myself, and you just give the steps. I'll do.
Yes, yes. Ma'am, you have opened HLX. You have to open Vivado. You have opened HLX.
Sir, by opening my version, it is opening like this only, sir. But it's working. I tried yesterday, today also.
Okay, proceed then.
It's a port names. What are the inputs, sir? D is the input.
Yeah,
D,
clock. Give the inputs are clock.
D clock, reset
Reset are inputs.
are inputs, and output is Q.
Output is Q.
Output is Q. Yes, sir.
Yes. Yes. All of you follow the same steps.
It's created, sir. D flip-flop
It's
dot
created.
B. So it is input D. Input is D clock reset. Output is Q.
Yes.
Already you are given the
Now,
code in the this, sir. Where I'm just
yes.
copying that.
Yes. First start with always block and in right positive edge.
Always at the rate of positive edge of the clock. If reset,
Yes.
if
Can maximize this link. Actually, it is very
I
small
tried.
on my lab.
Okay, sir.
Okay. Yeah. Proceed.
Yes, sir. Uh, it is if reset is not equal. I think exclamatory mark is given, sir.
Yes.
Uh,
No,
0
here
is
not
assigned
equal.
to Q.
Means make if reset. Don't put not equal. Q equal 0. Else.
Okay, if reset
Uh,
if reset
reset.
Q is 0, else Q is D is assigned to Q.
Yes.
That's all, sir.
Yes. That's it. Now that is the behavior of the D flip flop. Now sit and then compile it.
Yes, sir. Non-doc. Okay. Simulation, run simulation, behavioral simulation. If reset is equal to 1, error is there, sir. Mm,
Don't put reset equal to 1. Only simple if in bracket reset. What
that's
do you
always if in module. Some errors it is showing, sir. Run simulation, run behavioral simulation. Error, launch simulation failed due to earlier errors. Sir, can able to see this error, sir?
No, actually, your screen is very small for me. I mean, I am unable to recognize.
Errors. Compile step failed with errors. Please check the TCL console output.
Aruna, output reg q, reg.
Thank you, madam.
Output you have to reg.
It's compiling, madam. Executing. Rich. Okay. So we need to provide the D value as and providing as 1, sir. Clock. How to provide the input for clock?
Force clock.
Okay.
Sir, left అయినారు.
Force clock. Leading edge value. Trailing edge value. Starting.
10.
నెగిటివ్ పాజిటివ్ ఎడ్జ్ అని ఇచ్చాం కదా మేడం 0 to 1. Starting time the remaining all I'm keeping as same. Reset value will provide first value as 1. If reset is 1, according to our code, Q will be equal to 0. If reset is
Aruna,
madam చెప్పండి.
for clock 50 microseconds ఇచ్చినా ఇప్పుడు you are running for 10 microseconds కదా. అందుకే క్లాక్ సిగ్నల్ చూపించట్లేదు చూడు 0101.
ఓకే. సో 10 కాకుండా 50 పెట్టమంటారా?
1000 పెట్టు 1000.
1000 microseconds. Clock. Ma'am, it's have to zoom up. It is now showing. I think ఎక్కువ మిస్టేక్ చేసినట్టున్నాం మేడం.
డిలేనే ఎక్కువ వచ్చింది చూడు. 1000 తీసి
1000 తీసేసి 100 ఉంచుతాం. And 200 400 ఫస్ట్ తీసేసుకుంటుంది. So we'll close this. So clock initialization 50 microseconds ఇచ్చామా మేడం?
yes.
D force constant as 1. Clock force clock ఎంత ఇక 100 nanoseconds మ్యామ్.
నానోసెకండ్స్ లో
ఆ పీరియడ్ 100 nanoseconds, డ్యూటీ సైకిల్ 50%. 100 nanoseconds అంటే 5 మైక్రో ఇవ్వమంటారా? మైక్రో అయితే తీసుకుంటారు చూద్దాం. 0 1 reset value, force it as 1, then 100.
Madam, we can give any value, no problem.
Okay, sir. ఇప్పుడు వచ్చింది మేడం. ఇట్స్ చేంజింగ్ టు నేను 5 అన్నా 10లో 5 అంటే 5 10 reset force constant, reset value 0. మళ్ళీ I think 5. ఇక్కడ చేంజ్ అయింది చూడండి మేడం. అంటే యాక్చువల్లీ ఫస్ట్ 50 పెట్టాం కదా. ఫర్ ద ఫస్ట్ 50 మైక్రో సెకండ్స్ ఇట్స్ వాల్యూ ఇస్ రీసెట్ 1 ఇచ్చాం కాబట్టి రీసెట్ 1 reset 1, your output is 0. For the next I just change the time cycle as 5 microseconds. 5 microseconds by changing my reset as 0. If reset is 0, whichever the D value is there, that will be assigned to but whichever the Q value will be there, that will be assigned to D. That's okay, yes, sir?
Yes, ma'am.
Based on the times
Now D is
I'll change it
now
to
actually these flip-flop functions whenever the clock is reset is 0. So whenever reset is 1, output is 0. Whenever the reset is 0, output becomes equal to the D. That is what the behavior of D flip-flop. Now that is simulated here exactly.
so whenever the reset is 1, your output that is Q will be equal to 0. Whenever the reset is reset is 1, reset is 0, your output will be equal to your D. Yes, sir.
The same concept can be followed for all the sequential circuits. Here only difference is the coding style, and here for the coding style we will use the behavioral constructs whatever we have seen today, and the clock will be extra. Okay, here in the test bench we need to specify the clock, and already I given you the files where I have given the test benches also. There you can see
Yes, sir.
how
Here in the lab source, task 7 onwards, it is sequential. Task 7, D flip-flop, D flip-flop test bench is also there.
Yes, sir. For everything you can find test benches also. I give you test benches. And today I will be sharing some more Verilog HDL files along with the test benches. I suggest you to go through these files also. Today I am sharing another 6 tasks. These all 6 tasks are a little bit high-end tasks. High-end task means designing of arithmetic logic unit, designing of universal counters, design of universal shift register, designing of RAM, memory. All these tasks are given today. Now you know all the basic concepts, means what is HDL and how to write the programming, how to work with the tool. Now that knowledge will help you to understand all these files whatever I am giving you today also. You take the time and go through all the files and simulate all the 15 tasks whatever I am giving you. And if you face any problem while simulating, just post us, I will help you out. Now if you complete all the 15 tasks, then you will get enough knowledge to demonstrate your Verilog HDL skills. So am I audible?
Yes, sir. Yes, sir.
Yes. Now means today I will share some more 6 programs, ma'am. Let them practice. I think that is enough for them, okay, to understand all the Verilog HDL concepts. And if possible, you can arrange another one day. Okay, we will do if time is there. Otherwise, we will close the sessions with this concept. But because they know now, they have understood how to work the tool, how to work with the tool, and also they understood all the concepts of Verilog HDL. Then I give 15 tasks where code also provided, and if they sincerely implement all these 15 tasks, definitely they will get the enough knowledge. And for all the participants also, we request you to go through all the whatever tasks we have shared with you and implement them sincerely, so that you will get the enough knowledge. Karuna ma'am?
Okay, sir. I think we'll do one more based on that requirement, sir. If they want it.
Means you can take the poll from the participants. If they want, tomorrow we'll arrange one hour or 2 hours. where we can explain about all the tasks whatever we have shared with them.
Yes, sir.
Okay.
Actually, only 20. Okay, sir. Okay.
Okay. Just in the group we can post to complete all the 15 tasks by tomorrow. And if they have any queries, let them post, and tomorrow we will take one more session if they require.
Yes, sir.
But that by that time you can simulate all the 15 tasks, and then tomorrow you can project it. Why? Because I cannot project from my laptop. My laptop is little slow, and you can simulate all the 15 tasks, and tomorrow we can have the discussion on those tasks. Okay, you can project from your computer. I will explain from here. Okay.
Yes, sir.
Thank you.
Thank you, one and all, for attending this session. Any doubts? I think today only the basics followed by only one program. If you want to, Sir Tolna, if you
And
want
we
to
given you
do,
enough information how to handle the tool, and we given you how to write the program and how to simulate it, synthesize it, everything, and you have to practice it. So beyond this, we cannot do within 2 hours. Okay, whatever best we can do within 2 hours, we made it. And even though means it's not only 2 hours, every day we take in almost 3 hours. Okay, and still we are ready to take one more session if you like to see all the examples. That is tomorrow, day after tomorrow, ma'am will plan, and take enough time. Tomorrow, if you want 1 or 2 days also you can take, but ensure that all the 15 tasks should be completed before attending the final session. Is it fine, ma'am? Hello.
sir, if they are working they'll have the doubts or they want to clarify the doubts.
Yes, that we do. Okay, ma'am. Thank you. Thank you for the cooperation. And I hope I delivered the enough knowledge. But last day means if there is more practical session, then it will be within 2 hours. What best we can do, we made it. I hope, and I hope participants also enjoyed the session and they have got the enough knowledge. Thank you, one and all.
Thank you,
Stay
sir.
home and stay happy.
Thank you, sir. Thank you for taking the webinar followed by the virtual training session.
Still, it is not completed. One more session for the tasks we can open. And after the lockdown over, if they want to work on the FEGS also, I am ready to share the knowledge. Okay.
Thank you so much, sir.
Thank you, sir.
Okay, over to you, ma'am. Thank you.
Hello. Hello. Ma'am.
Audible, Aruna?
Okay, na ma'am.
Okay. If
Bind the
anyone
data, ma'am.
can ask, ma. Can ask.
You can ask any doubts sir, ID or mail ID, phone number, anything. If you want, you can ask. Sir asked to plan for the any doubt session, anything if you're working, anything you're working and you're not getting. You can post in the group, WhatsApp group. Thank you for attending this session and try to fill the feedback form to get your certificate. Ma'am, anything from your side?
If
Ravli ma'am, anything want to share? Anything useful?
The session is useful, Aruna. We need to practice more so that we can get full confidence.
That's what actually. If you're going to download the software, if you're going to listen the basics, then you can able to write programs. In the hardware side, like we have the programming languages. This is one of the programming languages. You can do the simulation and whichever the test bench waveforms we are getting now, and the parameters, synthesis reports, the parameters, power, delay, utilization, device summary. Those with that parameters, you can even publish the papers. You can search any what the concepts which are related to hardware. One of the programming languages, very ideal to write your programs, simulate it, synthesize, and even we can go up to fabrication part. That is, this part is under front end tools you can talk, and for back end you can go till fabrication also. Third tool, no, like a bitstream, all the steps are there here: synthesis, implementation, program, and debugging. All these you can do by using this tool. It is not a full-fledged, but it is an initiation for start your programming for your hardware side. Thank you, one and all. Indirama, wind up చేద్దామా?
చేద్దాం Arun.
ఓకే అండి.
If anyone have any doubt, post in the group mo.
వాట్సాప్ గ్రూప్.
WhatsApp group.
And
Wind up.
try to follow the video, then you'll get to have some doubts. Even though your doubts are not clarified, then you can post. Okay, already I posted the 2 days videos online recordings. Today also I'll post this record for basics and for understanding your this tool. Thank you, one and all. Thank you for participating, and thank you for listening, sparing your valuable time. Thank you, Nagraj sir, Ramesh, Amrita. Rajaram, Koteshwar Rao, Ayyappan. Thank you. Thank you, one and all.